Good morning everyone, I am VILLARMEA, and for today I will be tackling about the Earth's atmosphere, which we will be focusing on thermosphere. But before we start, let us first know the definition of atmosphere. Is one of the components of Earth's interdependent physical system. An atmosphere is made of layers of gases surrounding a planet or other celestial body. What is Earth's atmosphere composed? Earth's atmosphere is composed of about 78% nitrogen, 21% oxygen, and 1% other gases. These gases are found in atmospheric layers such as troposphere, stratosphere, mesosphere, thermosphere, and exosphere, defined by unique features such as temperature and pressure. What is the purpose of atmosphere? The atmosphere protects life on Earth by shielding it from incoming ultraviolet or UV radiation, keeping the planet warm through insulation and preventing extremes between day and night temperatures. The sun heats layers of the atmosphere, causing it to convect driving air movement and weather patterns around the world. What are the layers of atmosphere? The Earth's atmosphere has 5 main layers, from the lower layer to the highest layer. They are the troposphere, stratosphere, mesosphere, exosphere, and thermosphere. What is thermosphere? The thermosphere is the next layer, also called the ionosphere because of the presence of the ions in this layer. It starts from 80 to 85 kilometers up until 490 kilometers to 900 kilometers. The International Space Station orbits in this layer. Like the ocean's, Earth's atmosphere was waves and tides within it. These waves and tides help move energy around the atmosphere, including the thermosphere, winds, and the overall circulation in the thermosphere are largely driven by these tides and waves. Moving ions dragged along by the collision with the electrically neutral gases produce powerful electrical currents in some parts of the thermosphere. The aurora, or the southern lights and northern lights, primarily occur in the thermosphere. Charged particles, electrons, protons, and other ions from space collide with atoms and molecules in the thermosphere at high latitudes, exciting them to higher energy states. Those atoms and molecules shed this excess energy by emitting photons of light, which we see as colorful auroral displays. The size of the thermosphere depends on how hot the sun is at a time. Temperature here increases drastically, but there is no proper way to calculate this because of the presence of very few molecules in this layer, and also that they're moving rapidly. Much of the X-ray and UV radiation from the sun is absorbed in the thermosphere. When the sun is very active and emits more high energy, radiation in the thermosphere gets hotter and expands on or puffs up. Because of this, the height of the top of the thermosphere, the thermopause, varies. Many satellites orbit within the thermosphere, and changes in the density of brought on by the heating and expansion of the thermosphere generates a drag force on satellites. The boundary between the thermosphere and the exosphere above it is called the thermopause, which is specifically located at the height of the top of the thermosphere, and the bottom of the thermosphere is the mesopause. Although the temperature is considered part of the Earth's atmosphere, the Earth's density is so low in this layer that most of the thermosphere is that we normally think of as outer space. The thermosphere lies between the exosphere and the thermosphere. Thermo means heat, and the temperature in this layer can reach up to 4,500 degrees Fahrenheit. And that's all for this video. I hope you learned something from it. Again, this is CRIEST VILLARMEA signing off. Goodbye.